Hello everyone, now let's see the topic test the hypothesis of the significance parameters. So this is achieved in 5 steps. So first step is we have to write what is H0. H0 defines there is no significant difference between the parameters. And then H1 defines there is significant difference between the parameters. And alpha is the error. And TSS is the total sum of squares is equal to sum of squares of regression plus sum of squares of errors, and we represent this by a ANOVA table. And now let's see how to calculate SSR value. SSR is equal to summation of yi cap minus y bar whole square. SS is equal to summation of yi minus yi cap whole square. TSS is equal to summation of yi minus y bar whole square. Here yi cap is equal to the MLR equation, and here y bar means the mean of the sample y. F tab is nothing but f of k comma n minus k minus 1. Here k is the degree of freedom. In this question we are asked to test the significance of the parameter in multilinear regression. So they said to they mentioned as multilinear regression. So we have to find the MLR equation in this question and then test the significance of this MLR equation. So the process is same as the first question which we have discussed earlier to find the MLR equation. So let's go ahead with the process. So in this question we can see that there are 3 variables. So we have to use the case 1. Case 1 means we are having the y equation as beta naught plus beta 1 x1 plus beta 2 x2, and here beta naught, beta 1 and beta 2 are the parameters, and these parameters can be estimated by the normal equations. And those normal equations are, so these 3 are the normal equations to find beta 1, beta 2 and beta naught values. So now we want the values of x1 square and x1 x2 x2 square x1y and x2y, and after finding these individual values we have to then add summation of y. By adding summation of y we get 50, summation of x1 we get 41 and summation of x2 we get 49. Now let's calculate the value of x1 square. So 2 into 2 is 4, 4 into 4 16, like that we have to find all the rest of the values. These are the values we get after solving the values of these individual variables. Let's substitute these values in the normal equations. So these are the values we get after calculating all the values. So now let's enter these values in the calc. Beta 2 is equal to minus 1.13. So now we got the beta 1 and beta 2 values. So we have to substitute these values in the MLR equation. MLR equation is, so now y is equal to beta naught is 9.31 minus 1 is 0.14 x1 minus 1.13 x2. So this is our MLR equation. Now that we got the MLR equation, now we have to find the table for calculating y cap. We need summation of y cap. Now we got the table values. Now we have to find the TSS. Find the summation of y1 minus y bar whole square. The value of TSS. Now we know the value of TSS. TSS is nothing but the total sum of squares is equal to total sum of squares is nothing but y minus y bar whole square, which is equal to 177.6. Sum of squares of regression is equal to summation of yi cap minus yi bar whole square is equal to 36.25, and SSC is nothing but sum of squares of error is nothing but summation of y bar minus SSE is equal to summation of yi minus yi cap whole square, which is equal to 80.13. So from this TSS, SSR and SSC we can find the ANOVA table. Now let's see how to calculate the values in the ANOVA table. So in the ANOVA table we have degrees of freedom. Degrees of freedom is nothing but k is equal to number of variables. K is nothing but number of variables, which is equal to 2. That is, we are having x1 and x2. So now we have SSR. SSR is nothing but k value is as k as 2 and n is 12 minus 2 minus 1 gives us 9, and then n minus 1 is nothing but 12 minus 1, which is 11. Now let's calculate the value of MSSR. MSSR is equal to 80.13 by 2, 40.06, and MSSC as SSE is nothing but 36.25 by 9, which is nothing but, which gives us 4.026. Variance can be calculated by, variance is calculated by FCAL is calculated as MSSR by MSSC, which is equal to 40.06 by 4. Calculating this value, we get it as 9.95. F tab is calculated by the formula f of k comma n minus k minus 1. So by using the table, so now let's calculate the tabular f, the value of f in the from the tabular columns. So this is the table we have. From this, let's check the f table. So this table represents the f distribution. Here we have to check the value of k as v1. We have k as 2. N minus k minus 1 is 9. So let's check where is the 9, and 9 is here. So we have 3.86. The k value is 3.86. F value will be 3.86. So now F cal is greater than F tabular value. So that implies we reject H naught.